All right, everybody. So let's get started for today's session. Welcome, everybody, to today's online PhD level class in climate finance. For those of you who are new to the sequence, my name is Johannes Ströbel. I'm a professor of finance at NYU Stern. The plan for today is very similar to what we, what we did in previous sessions. So I'm going to start out with some sort of general high-level observations, of me personally about sort of this, very, interesting and exciting and emerging research field of climate finance. After that, I'll present a research paper, that I wrote with some co-authors earlier this year on hedging climate change news. After that, we'll have 6 other presentations. So 6 other, research teams will talk about, their work and their recent papers in this space. And at the end of the day, we'll have, a moderated panel where, all of the presenters who are available will kind of come together and we'll sort of discuss a little bit sort of, in a forward-looking way, not only what is the research that we have done in the past, but really also discussing much more about sort of the research directions that sort of we find exciting and hopefully some ideas will come out of that. I want to remind everybody that this is done in a webinar style. So if you have any questions to the presenters, what I would ask you to do is to put those in the Q&A, and then I will try and weave them in to the overall discussion at the end. So the idea is that the presentations are sort of 30 minutes and we'll keep those uninterrupted, and we'll sort of have this panel discussion at the end where I'll try and group questions together and bring them in into that. Okay, so research in climate finance. In some ways, this class that Teresa and I, have put together, the sort of overall topic of it is, empirical household finance. And so this last section, is a little bit out of topic, though only a little bit, as you'll see in many of the presentations today. And the reason that, we both felt very, very keen to have this session on the program, despite the fact that it, in some ways transcends household finance, is that, to us and, to many others, starting out with a quote from the UN Secretary General here, is that really climate change is really one of the defining issues and the defining challenges of our time, certainly, of our generation. And, we feel that as social scientists, we should try and speak to what the the important and general issues are facing society, and so climate change is obviously amongst them. Now, traditionally, within the economics profession, most people who thought about climate change would fall into the the subfield of environmental economics. But what's happened more recently, and you'll see this in a lot of the presentations today, is that researchers are starting to use the tools of financial economics to think more carefully about climate change. So really trying to use the tools and insights coming from finance. And, I'll make the argument that those are actually quite sort of different ways of thinking about the issue than, say, the way that environmental economists think about the issue. And I think that, we as financial economists, broadly speaking, we actually have a lot to contribute to this. And so, some of these research papers we'll have today, they'll give you examples of that, but I really think there's lots and lots of other directions. Why is this being the case? I think there's twofold. One of it is just there's an enormous pressure coming from financial markets, right? So both financial regulators and financial market participants are realizing that risks coming from climate change will dramatically affect financial markets. They already are, and they will do much more so going forward over the next year. So I'll give you some examples of that. But secondly, if you think about climate change, it really, the way that you would think about it in a model is as an aggregate risk to the economy. And, financial economics, has developed many of the tools to think about and manage and price risks in many other settings. And, there's a lot of opportunity for intellectual arbitrage to go and take some of these insights, take some of these tools that we use when we say think about consumption risk or something in the stock market, and apply those thinking about climate risk. Now, as we'll sort of work our way through the sessions today, we'll realize that climate risk is going to be different on a bunch of dimensions and a bunch of important dimensions. But I think a lot of the basic insights still apply. So Again, why climate finance? So this is, from a report of the Market Risk Advisory Committee of the CFTC, one of the, preeminent financial market regulators in the US. This is a report that came out this September, and the introduction of the report really, kind of puts in very, very stark terms why it is going to be impossible for financial markets to not think about climate risk as one of their preeminent risks going forward. It says climate change poses a major risk to the stability of the US financial system and to its ability to sustain the American economy, right? And then, talks that, even under the most optimistic, emission reduction scenarios, we already have a lot of global warming going forward priced in. Right. So even if Joe Biden, starts enacting very aggressive climate regulation, etc., we already have baked in a lot of increases in the climate. And, this reality poses complex risk for the financial system. Right. And so what are these risks? They include disorderly price adjustments across various asset classes, possible spillovers into different parts of the financial system, potential disruptions of proper functioning of financial markets. Right. So really, this is going to be a first order risk, and the financial regulatory community, starting with, say, the Bank of England and the ECB, who've thought about this for much, much longer. But in the last month, the Fed, has started talking about climate risk in its financial stability report, which it had never mentioned before. So even in the US, the regulatory community very strongly starting to realize that climate risk is important. The other side is the financial market. So this is from Larry Fink's 2020 annual letters, to investors. It's kind of, a staple in financial markets when Larry Fink, the CEO of BlackRock, the largest asset manager in the world, goes out and kind of gives his views once a year on, on where the financial markets are going. And he says, look, climate change has become a defining factor in companies' long-term prospect. And it says it's a risk that markets to date have been slow to reflect, but awareness is rapidly changing, and I believe we're on the edge of a fundamental reshaping of finance. Right? What are the directions that he thinks going to refinance? And a lot of these actually sort of directions that are going to be covered by the papers we'll see today says, will cities be able to afford their infrastructure need as climate risk reshapes the market for municipal debt? So we'll see Paul Goldsmith-Pinkham's presentation, and we'll talk about climate risk being reflected in municipal debt. What will happen to 30-year mortgages, a key building block of finance, if lenders can't estimate the impact of climate risk and if there's no viable market for various insurances? So both, Nancy Wallace and, Matt and Amin's paper we'll talk about the effect of climate risk on the mortgage market. What happens to inflation and interest rates if the cost of food climbs? How do we model economic growth? If we're going to see actual productivity declines because of extreme heat and climate impact, right? And so as a result of all of these concerns, investors are increasingly reckoning with these questions. And it says that these questions drive a profound reassessment of risk and asset values in the near future, and sooner than most anticipate, there will be a significant reallocation of capital. Right? So both in the regulatory community and in the financial market community, you see that climate risk and climate change is really the hot topic when you talk to participants in each of these two. Not because it's the only important risk, but it is a very important risk that these communities are struggling to understand, only learning to understand about now, and and as a result, I think where there's a lot of scope for creating relatively new insights. And as I said before, as a research field, climate finance is very new, and I really think poised to become much, much more important. And like all relatively new research field, it has this beautiful, feature that many first order questions are actually still unanswered, right? So topics that people have thought about for 30, 40 years, on most questions where progress can be made, progress has been made. I think in climate finance, there's many, many first order questions where just by the nature of this being a very, very new topic, many first order questions are unanswered. And as a result, and I know a lot of the people in the audience are, graduate students who are sort of looking for topics to think about writing dissertations on, etc. I think graduate students have, in some sense, particularly if you're in a second or third year graduate student, you have the disadvantage that you have to be somewhat forward looking. You can't just be writing a paper that's going to be interesting next year. You have to sort of predict what will be interesting 3 or 4 or 5 years from now when you end up going on the job market. And quite often, that's not the types of topics you see most heavily heavily presented in your seminar series at a given point in time. Why? Because what's being presented in seminar series at this point in time is basically what people were excited working about 3 or 4 years ago. And if you then go 3 or 4 extra years into the future, people might be relatively bored by those topics already. I think climate finance, precisely because it is very new, it is a topic that's really only going to grow in importance, is a fantastic one to to start looking for opportunities for graduate students who kind of face this dilemma a little bit. So, the hope is that today's presentations and the discussions afterwards will give you some ideas about possible topics to work on, possible directions to take your research. What I'm going to do is I'll very briefly talk about sort of, a bunch of high-level topics that I think, fit neatly under this climate finance umbrella. I want to point you guys to a recent review article that I wrote with Stefano Giglio and Brian Kelly for the annual review of financial economics. I attached it to the email that was sent, but you can also find it on my website, where we also trying to summarize sort of, the state or some of the topics, in this very new field. So in terms of research topics, research things you would think about in terms of climate finance, I would think that, a lot of the papers today are going to be largely empirical. But I actually want to start out with sort of some theory topics that fit very nicely. Because, once you think about climate risk, you want to start wondering about, well, how would you go about introducing climate risk into your macro finance models? And you want to know, what are the sources of uncertainty in the model, right? That's the first thing you need to take a stand on, right? Is the underlying source of uncertainty uncertainty about the economic activity? So you could write down a model where, consumption and economic activity is still the central driver in the economy. And then climate is, the climate is related to the economy because, CO2 is an output of economic activity. And so when the economy is doing well, we have more CO2 that leads to more climate change, right? So that's one way of approaching this. There's another way that you can approach, where you really make the climate and the path of the climate the direct object in your model about which you're going to start introducing uncertainty. And then really what's also important here is that there's a lot of important stands you need to take on the interaction between the climate and the economy. So it's going to be feedback loops going both directions, right? Economic activity produces CO2, which leads to more climate change, and then climate change, through these, including some of the things that, from the Larry Fink letter, can feed back into economic activity, right? And a lot of these processes likely are nonlinear. You can think about, tipping points, climate disasters, etc. So there's really a lot of important decisions you need to make in terms of how to introduce climate risk into macro finance models. And what's really interesting about those decisions is they're going to be to substantial and to a substantial degree determined by sort of getting a good understanding of the physical processes of climate change, right? So really like trying to learn from the physicists and the meteorologists and climate scientists about what these feedback loops might look like might help us include them in our models. Now the decisions that you take on these three topics will have very, very important implications for the pricing of climate risk, and I'll talk about some of these later on. There's also, an important role in some of these models, and Lars Hansen has done some fantastic work on this in the last few years. It's about the role of ambiguity, right? How do you think about an economy where there's just true uncertainty about the probability law, true uncertainty about the model relationship? It's not only do you have a climate process and you draw IID shocks. What if you don't even know the underlying parameters of the process? And how do you think about, introducing climate risks in those types of scenarios? In some ways, there's obviously these trade-offs where, if you talk to the climate scientists, they use supercomputers to try and, sort of get these physical processes of climate risks appropriately modeled. And, we obviously do not have that ability because that eats up any tractability you have, and then you can't do interesting economics with climate in there. But I think as computational power increases, we'll be able to integrate more and more realistic physical models of climate change into the macro finance world, and the interactions between those two. And I think that's a very exciting space. Ken Judd has done a lot of interesting work there, on the computational frontier. Stefano will present, a much more simple, much more reduced form model, in his presentation. Those, in some sense, these are two extremes in terms of how abstract you want to make the climate process. But I really think there's a lot to be learned, by actually going and talking to the climate scientists and sort of, using the guidance we get from that to then, thinking about how to include this in our model. So I think, there's a lot of theory work that needs to be done. And then the next one is sort of at the intersection of theory and empirical work, and so how do you think about valuing investments in climate change abatement? This is a very first order problem, also from a practical perspective, because many projects, many regulations, in the US, this is sort of restricted, or this is mandated by law, require to do a cost benefit analysis, right? And so if you want to, put in a climate regulation, what you have to do is you have to, figure out, does it beat a cost benefit test. And so you're going to spend a lot of money today, and some of the benefits of that, in particular for climate change, where some of the worst damages might only happen in the sort of intermediate future, sort of 50, 60, 70 years from now. You have to sort of figure out at what discount rate are you going to discount these sort of benefits that occur in the very long future. Now, what we quite often do is we look at market discount rates when we're trying to get discount rates for for asset classes. The problem is that the very long run nature of the investments mean that the discount rates from the types of usual finite horizon investments that we observe traded in financial markets are sort of difficult to get at. And the papers presented by Matteo Maggiore and Stefano Giglio later on, will show you some attempts, from some of our work in terms of how to address this and how to use financial markets to better teach us about climate risk. What's also really, really important here, and I think this is the first place where, when I first got to this climate finance literature, where I really felt that financial economics has really valuable perspectives to add to sort of more environmental economics, is that as financial economists, we think a lot about, when we think about discount rates, we're really trying to compose them right away. So, well, what part is risk free and what part is a risk premium, and they start thinking about preferences, etc. But actually, what turned out is that many people in the climate world, they don't think about discount rates are sort of related to risks and related to covariance. So in some ways, when they're trying to figure out discount rates, what they will do is they will say, well, and this was, an insight that people had proposed. I'm saying, well, look, one of the things that matter here is, think about it as an opportunity cost approach. Like I could, I could put the money in the stock market and that gives me 7%, or I can, invest in climate change abatement. So the idea would be that the benefits from climate change abatement would have to be discounted at the same discount rate as this, stock market, the opportunity cost. And what a financial economist would obviously say is, well, no, that's not how it works, right? The stock market is a risky investment, while an investment in climate change abatement might well be a hedging investment, at least depending on on the types of covariance properties that you decide on in these modeling frameworks. But under most of them, climate change is a huge economic disaster, and so if you avoid climate change, this really pays off in a bad state of the world, and is therefore a hedging investment, and therefore the discount rate should actually have a negative risk premium. And so you shouldn't just take a discount rate, say, coming from the stock market, which is a positive risk premium, because it's a risky investment that primarily pays off in good states of the world, right? So really thinking about covariance risk and risk premia is something that we as financial economists were very much trained to do, but it is something that is at best sort of relatively new to the environmental economics literature, and I think it's still missing from a lot of papers. And again, this will have sort of important implications for the pricing of climate risk and other things. So Stefano and Matteo will talk more about these topics. And then sort of going really much more into the empirical side, right? You want to think about the pricing of climate risk, like how are financial asset values reflecting climate risk already? And when you start thinking about that, you start realizing, well, we've talked about climate risk, but it's not really such a straightforward, simple concept. And in fact, there's quite at least two, maybe even more different types of climate risks that you want to think about. So the first one you think about is physical climate risk, right? So these would be damages that come, directly from the, physical damages that that climate change will bring. So you could think, for example, physical risk being, if you own coastal real estate, this is really going to be exposed to the physical risk of climate change because, when the sea levels rise, it might end up being flooded. But there's a second category of climate risk, which is probably, if you think about most financial markets today, maybe even the dominant one that's being priced, which is transition risk, right? So the people here the idea is, well, at some point climate change will get so bad that the regulatory actions will will come into place to shift us to a low carbon economy. And in that process, that poses a lot of risk for certain types of firms, say if you're in the oil industry or something like that. So this type of regulatory risk, alongside that technological risk, is related. So as we worry more and more about climate change, we might invest more and more in in research and R&D and so on to reduce carbon emissions. And if you're an old school German car company, the technological change of the the electric vehicles, etc., might well be a fundamental transition risk that you have. There's also a thought of legal risk, right? So people compare this a little bit to, say, the tobacco lawsuits. The idea that these people were knowingly doing active damage to the world, the tobacco companies, and therefore got sued in courts a lot. That there's a chance that similar things may well happen to energy companies and so on. So, the way I usually think about is these two types of risk, the physical risk and the transition risk. And what's interesting is the two can interact in very interesting ways, right? So if you think about, say, putting in stringent climate regulations, say carbon tax or something like that, that type of regulation is a realization of regulatory climate risk. So it's going to be bad for energy companies and so on, oil companies, but it might actually down the road reduce the probability of realizations of physical risk related to climate change. And so there's interest, when it's not just a unidimensional thing, but it really is sort of a multidimensional object with various aspects that don't always move in the same direction, might in cases even move in the opposite direction. And then the second thing that's really important to realize is that different assets can have very different exposures to these risks, right? So, said differently, climate change can have winners and losers, both on the physical climate risk and on the transition climate risk, right? So if you think about, the regulatory climate risk, Tesla and Exxon might actually very well have different exposures to this, right? So if a carbon tax comes in, that's going to be very good for Tesla. It's going to be very bad for Exxon. Similarly, if you think about physical climate risk, right? As sea levels rise, as it gets hotter, this is going to be, pretty bad for coastal real estate in Florida. But might actually be good for, Midwestern real estate where, temperatures are now rising. It becomes, maybe the land becomes easier to farm, or maybe it becomes easier to live. So even on the physical side, there's going to be winners and losers. So you want to think about climate risk, thinking back to the models, it's clearly a negative aggregate risk to the overall economy, but it still will have winners and losers. And so a lot of the work, that we'll see today will try and understand, the extent to which it is priced already in different markets, the way we measure these types of exposures, etc. So this is, really, a really important challenge that we're going to be, discussing a lot today, which is once you realize, different assets might actually be differentially exposed, you want to start wondering, well, how do you measure climate risk exposure, across asset classes and within asset classes, right? So if you think about stocks, for example, you want to think, well, which stocks are positively exposed to risk and which stocks are negatively exposed to risk. And so one approach you can take is you can think about, ESG scores, maybe as one way of if you get a high energy score, you're very environmentally friendly by some of these ESG score providers. Maybe that tells you you are negatively exposed to regulatory risk, and if you have very low E scores, you're positively exposed. There's a lot of really exciting work being done by people, exploring various types of, say, public filings, earnings calls, discussion, etc. And so Zach's presentation in a bit is going to, give an example of exactly this, of trying to sort of use sort of novel sources of data to try and tease out, differential exposure to both regulatory and physical climate risk. Then there's obviously, you can think about physical risk. You can say, well, what really matters is the location of production facilities. But really, why stop looking just at the firm? Different firms might be exposed through their supply chains, they might be exposed through their customers and so on. So there's it's a very complex object to think about. Similarly with real estate and mortgages. So we're going to see 3 papers today that that going to talk about housing markets and mortgage markets. In part because housing, as an asset class, is really uniquely tied to location. And to the extent that you think climate change is very location specific, thinking about an asset that's really tied to location, makes a lot of sense. So, again, I already talked about the coastal real estate versus, non-coastal real estate, etc. And then if you think about fixed income markets, right? Lots and lots of different markets you could look at. But for example, when you think about municipal and sovereign debt, again, the location might matter for the different countries. So Paul's presentation is going to, explore the extent to which, and the municipal debt of municipalities that are, say, in coastal areas, and where maybe the tax base might get destroyed by climate change, whether or not those trade differently. But even you think about this at a national level, right? Singapore, the Netherlands, Bangladesh are countries, that are very, very strongly going to be, Maldives, etc., Fiji, countries where when sea levels rise, these countries are going to be under huge pressure. And so this, is likely to be reflected in sovereign debt risk. You can even think about regulatory risk being priced in sovereign debt markets, right? So, if you're countries in the Middle East or Norway with a very oil-dependent economy, right, those might be countries where in the sovereign debt markets you're going to get a lot of negative exposure to, to regulatory climate risk. Similarly, if you think about, so lots and lots of different asset classes, you want to think hard about sort of the various ways that they're exposed to these different categories of risk, physical and regulatory risk, and then, how you measure the extent to which that is already priced in financial markets, and, trying to forecast the extent to which this will be priced going forward, as markets pay increasing attention to this. Now, with these exposure measures, you can then, again, test how you do that. What can you do? Well, you can, explore whether or not exposed assets, say, have sort of alphas relative to, your favorite asset pricing model. You can also explore whether or not exposed assets move differentially, on the news about climate risk. The challenge we have in all of these papers, I think, is just that there's an extremely short time series for all of these analyses, right? So, we know this in finance, like, measuring alphas relative to asset pricing models, we feel even 40, 50 years of data, it's not really all that much data. With climate risk, this is a much, much more fundamental problem, because, we think that climate risk is likely priced in financial markets today. I'm pretty certain it wasn't really priced in financial markets in the 1980s and 1990s. And so, you're going to have trend breaks in your asset pricing models, which means the time series over which you could actually explore this, they're actually much, much shorter than even what we're dealing with, in a lot of other asset pricing. Part of that is why, a lot of the research papers you'll see today are doing a lot to exploit the cross-section rather than just, you trying to do time series analyses. It's just fundamentally very, very difficult. And then lastly, and this is the paper I'll talk about it and start talking about it in a few minutes, you can start thinking about the extent to which, if different asset classes are exposed to climate risk in interesting ways, how can we actually use financial markets to hedge this risk, right? Because I think in many ways, this is a fundamental role of financial markets, is to transfer risk to those individuals who are best able to bear it. And so once you understand, which assets have differential exposure, you can, and I'll talk about this today, you can think about forming hedge portfolios, and those hedge portfolios will allow you to, down the road, reduce and hedge the importance of that risk. The last slide, and this is more just speculative before I go into presenting some actual research, it's just a non-exhaustive list of just other interesting questions in this space, that I think, deserve more attention. There's a lot of work going to happen, in terms of additional disclosure, right? So, if you think about why does Zach have to go through his process of, measuring climate risks through these sort of, various complicated ways, it's because these are important risks on which we don't have a lot of disclosure for. Now, regulators talk a lot about disclosure. It's actually very hard to know what it is that you'd want to know from different companies in order to judge their individual climate risk exposure. It's a few obvious things like, well, how carbon intensive is your production process, etc. But there's a lot more than that, and it's really not obvious. And I think a lot of research is required to get this right. If we're going to ask companies to disclose this stuff, let's actually figure out what is useful and what it is that we really need to know there. There's a lot of interesting, effects of investor engagements on firm behavior. So, actually, Zach has a paper with Laura Starks, where they survey professional investors, and one of the interesting findings there is that climate risk and climate change is really a first-order topic that investors bring up with their portfolio companies. Larry Fink said the same in the letter that I started the presentation out with. And so there's really a first-order issue. Well, what does that do? So if you're an investor, what do you ask your companies to do? How does that engagement actually affect behavior down the road, I think is interesting. Then there's a sort of a very large and important industry, financial services industry, the insurance industry, which, in many important ways is directly going to be affected by climate risks. Reinsurance, the insurance and the reinsurance industry, I think, are both very important here. If you think about, hurricane damage, etc. So really thinking about, that industry in the context of climate risk is something that I think we should be doing more of. This is an interesting, I think the insurance industry for many years sort of understudied relative to its importance in, in financial economics. And that's changed over the past few years. Ralph Kogan, Moto Yogo, and a bunch of others have really started to, hone in on understanding the insurance industry. But, the focus hasn't really been on that interaction with climate risk. And I think there's a lot of interesting topics in, in that space. Then one other question, we talked about, climate risk of individual assets, but there's sort of a second question that's not as obvious, which is the extent to which climate risk is really a systemic financial risk, right? So when it realizes, does it have the same, the same type of ability to dramatically disrupt markets, or is this, a risk that, will destroy some value for some people, but it is not going to be systemic? And I think in order to do that, we really need to understand, who the residual holders or claimants to this climate risk are. So, once we understand the asset level exposures, right, we really want to understand who's actually eventually exposed. And so, the presentation by Amin and Matt Khan is going to really dig into that, because in the mortgage markets, it's actually very, when you think about general default risk, actually sometimes very diffuse about who's the eventual holder of default risk in mortgage markets. And climate risk is going to be very similar in a bunch of these dimensions. And then lastly, this is a topic that I've thought a fair bit about, but I think it's it's important, and it's where finance interacts with urban economics, spatial economics, a bunch of other areas too, where we're really trying to understand, the general equilibrium effect. So imagine, in the spatial world, there's going to be some regions that are going to be benefiting from climate change, some that are not. How are you going to see, migration across these regions? This could be across country migration too. So there's already a lot of debate, say how, the migration waves out of Africa over the last decades, to some extent were driven by climate change. And you can think about that. You can also think about the general equilibrium effects of investor behavior. So let's imagine investors are very good at figuring out which companies, are very bad for the climate and which companies are very good for the climate. If they then all reallocate their portfolios, this will increase the cost of capital for the oil companies or other companies that are bad for the climate, and reduce the cost of capital for, say, the solar, wind, whatever it is that's good for the climate. And so part of the question is, how much can that capital allocation by itself allow us to actually affect the path of the climate going forward, right? So thinking about these general equilibrium feedback loops, you may have to take more of a stand on the theory side that I talked about earlier on in the presentation, but really trying to link those and really understanding. I think that's, that's an ambitious agenda, but, I think eventually this is where we'll want to end up. Right. So that's really, all I want to talk about in terms of like big picture overview. Again, you'll see how the various different presentations we'll have today fit into, to these topics. And this clearly isn't, the only set of topics that are important. But, it gives you a flavor of the types of things that maybe if you're a PhD student, you might be interested, in exploring.